plt.close, just to close them all. And now I'm gonna load MNIST data from OpenML. So this data set actually gets quite large. And so every time you run the code, if you have to reload it, can take quite a bit of time. So if you haven't been using F9 to run code line by line, now might be a good time to start. So I'm going to go MNIST, MNIST, is equal to sk.datasets.fetch underscore OpenML, call it MNIST underscore 784, and that's the number of pixels per picture, 784, comma, as underscore frame equal to false. Oh yeah, so import matplotlib.pyplot as plt. Oop. And then import sklearn as sk. From sklearn import data sets. There we go. All right. So it's still loading data. I'm just going to let it go ahead and do that. Okay, it has now loaded the data. I can open up MNIST, and I can open up the data. I can open it, but it's pretty large, and I don't want to crash my computer. So let's kind of parse the data set out with code. So let's just say print MNIST list string description, DESCR, all capitals. That's what you don't want to do. Don't hit F5. And that will print your description, print the key, PRINT. All right, I'm going to go home, shift, N, F9. I didn't like it. Okay. F9. There you go. So that'll tell you about the data set. Authors, source, data set. It's a subset of the larger set available from NIST. The digits have been sized, normalized, and centered in a fixed size image. Good database for people who are trying to learn techniques and pattern recognition methods in real world data while spending minimal effort on pre-processing and formatting. Boom. Exactly what we want, right? We just want data. So let's call it X is equal to MNIST data, because I'm tired of typing that. And we're going to go Y is equal to np.asArray, because it doesn't give it to you as an array, and we want it MNIST target, comma D type is equal to int. That should make it an integer. Okay, so MNIST. All right, now I got X and Y. So resave the data as X and Y. All right, let's go ahead and pick a digit. So fives are actually kind of hard to classify, right? A 5 can kind of look like a 3, and we'll go over that in a bit, but for now you can just trust me. So I'm going to go digit underscore ID is equal to 35. This is an OK looking 5. I've just kind of dug through the data set and I found a 5 that looks pretty good. So we're going to go test underscore digit is equal to x digit underscore ID. So I'm going to get row digit ID for all of my columns. And that should go ahead and give me a test digit that looks like this. These are the gray values between 0 and 256 of your 5, but they're not in a picture format, right? They're just 784 values in a line. But if we were to rearrange these, maybe we can get a 5 out of this. So something that we have to do, we can go digit underscore reshaped is equal to np dot reshape test underscore digit test underscore digit. Now I need to feed it a tuple of what I want to reshape it as, and I want to reshape it as a 28 by a 28 because that's what the picture is. And now I should be able to run that. And I should be able to see digit reshaped. Okay. And now I have this beautiful image of a 5. Kind of abstract because my pixels aren't square, but that kind of looks like a 5, right? Elongated 5. But we don't want to look at it like that. Actually, I might be able to go show image. Oh, there you go. There's a 5. That looks a lot better, right? So that's an okay looking 5. So we can go P. So let's plot the 5. PLT dot figure. PLT dot IM show digit underscore reshaped comma CMAP dot CM dot binary comma interpolation is equal to nearest. And I'm going to see if that image looks pretty good. CMAP is not defined. CMAP, oh, sorry, CMAP is equal. That makes more sense. All right, CM is not defined. So do I need to import CM? Oh, MPL, matplotlib.cm. So I need to add that up here also. Import matplotlib as MPL. Run that through an F5, run that through an F5, and I should get, there we go. I get a nice 5 digit, kind of written how you would expect, right? Like a black pen on a white page. So we can add a title to that if we want. Let's go ahead and add a title, plt dot title. Let's say A. I think I can go plus str y, which is my target, digit underscore ID That might work. Let's see if that works. A 5. That works, but it's kind of lame looking. A 5-digit. I'm going to go a 5-digit. That's a perfectly fine title. All right, and now it knows what that is supposed to be. Okay, so let's go ahead and look at some other 5s that aren't so great. So 0 is also a 5. But it is not very 5-y. Is that a fair way to describe that? Like if I know I'm looking at digits, I only can pick between a few, maybe 5, but it could also be a 3. Probably couldn't be a 2. So that one's not great. And then 100 is another 5. Is that a 5? Sure. But so this one's pretty hard to classify, right? This one's pretty hard to get a machine learning model to say this is a 5. So that's kind of the beauty of the MNIST data set, is that it's not always perfect, if that makes sense.